Now let's talk about nets. Not the Brooklyn Nets, but a net is, imagine you had a 3D object and you just flattened it out. And that would be the net of that object. Now, when you draw a net, it doesn't have to be all connected. I don't know if they still do this, but when I was a kid, they used to have things in the back of a cereal box where you could cut it out and fold it up and make like a cool shape, like a, I don't know what, like a, let's say like just like a cube or something. Well, the net would be the flat version of it, and then once you fold it up that into a cube, then that becomes a 3D solid. So nets are great for being able to find surface area, and that's what we're going to do in our next section. Surface area is just the total area of all the polygons that make up the polyhedron. Alright, so I'm going to write down the definition of a net as the 2D representation of a 3D figure. Okay, so let's practice drawing some nets. So I'm going to draw the shape as a 3D object first, and then I encourage you to pause the video and then try to imagine what the net would look like. Maybe for the first one, you might want to see how it's done, but if you're feeling ambitious, go for it. So, not the best picture, but that would be a pentagonal pyramid. Notice how the base is a pyramid, and then these all 5 points of that pentagonal base, you draw a line from there and they meet at one point. Alright, now I want you to draw out what it would look like as a bunch of 2D polygons. Okay, so that's what I got here. One pentagon in the middle, and I assume it's a regular pentagon, and then 5 triangles where all the triangles have a length of the base that's the same length as the sides of these pentagon, and then the height of these triangles would be what's called a slant height. So the height of this triangle wouldn't be the height of the pyramid, like from the top straight down. That wouldn't be the case. It would be the height on like a slant from the side of the pyramid to the vertex. Now if you wanted to draw it as like a pentagon and then just like 5 triangles, that could be another way to draw the net. Okay? So now I would pause the video and try to draw the net of a cylinder. Okay, so there's a cylinder, and so it's going to have 2 bases that are circles, and for the rounded part, alright, imagine like a soup can, right? That's a good example of a soup can. Alright, this part is what we're going to try to draw. Now, if it was flattened out, that would be like the label on a soup can, which always forms a rectangle if you ever flattened out a label on a soup can. So that right there would be an example of the net of a cylinder. You could draw it different ways, but separately together, but as long as you have a rectangle and 2 circles, you're good. Okay, let's draw the net of a triangular prism. So there I have a triangular prism. I drew kind of equilateral triangles as the bases, but based off the name, you don't know what type of triangles the bases are. You just know the bases are some type of triangle. And notice how all the sides, the faces between the bases are rectangles. So here's what the net would look like, and you don't need to draw it out as one object, like connected. You could just draw it out like this, where you have 2 congruent triangles as the bases and 3 rectangles. Alright, so that's a common thing. With prisms, you're going to have rectangles that are the shapes of the non-base faces, and for pyramids, you're going to have triangles that are the shapes of the non-base faces. Alright, so let's do a cone now. So if you want to pause the video and draw the net of a cone, now would be a good time to do that. Okay, so that's what a cone would look like. So one part of the net would be a circle, and the other part would look like a sector, like a piece of a circle, where like if you were to like kind of fold this back around, it would form this outer part of the cone. So that's the best you could kind of do here. This slant height here, from here to here, like the radius of this sector, we'll call it L because we're going to use it as a slant height, would be like this length right here. And like that radius is the same as that radius there. Alright, I'm just going to pause the video and pull up a better picture of the net of a cone so you can see what it would look like from like a textbook picture. Okay, so that was what I was trying to draw there over on the right here, where it says base and lateral area. That's another representation of the net of a cone.